Cool. Well, let's go. I'm unmuted for reals on the lives. How do we get video back? There we go. Well, hello. Welcome everybody to the 76 Dev Show and Tell, another one. Today we're hanging out with Spacemandev. He's going to show us some cool experiments he's doing with Solana and compression. I don't even know fully what we're going to dive into yet, so I'm excited to see what this is. Do you want to maybe give, I think we're all familiar, well, I don't want to say all familiar, but maybe if some people have heard of like compressed NFTs before, maybe what's like a segue into what you're messing with?
Yeah, so basically, if you're not familiar with Solana, Solana is an L1 blockchain. On the EVM ecosystem, one way to scale is something called like L2s and rollups, right? On Solana, the way to scale, the magical way to scale is something called compression. Compression is effectively the best version of an L2 that you can think of. It's a way to write data off chain, but verify it on chain that anyone can do. So how does that work? Well, compression uses a couple of really neat hacks. One of the things that, unlike EVM, Solana, you can't write transactions to, or you can't write to transaction logs, which is something that is preserved in EVM. That's how they do a lot of rollup stuff in call data. So in Solana land, what we do instead is the way to preserve data on chain in the ledger instead of in the memory state is to return data through a function call. And so there's a program called the SPL NoOp program. You take data, you send it data, and all it does is return data back to you. That return data is saved in the instruction logs or the transaction logs. This allows you to index data by the RPCs while still having it be stored as a hash on chain. So you can take that data, you can hash it, you can throw it in a Merkle tree, save the Merkle tree on chain. So now you have like, 32 bytes that you're taking up on chain, maybe a little bit more. And then you can then set up RPC providers that will index every time one of that return data is called and update the actual data, the deserialized data on their RPC. And whenever you want to verify it, you go fetch the data from the RPC and you're able to check it against the hash of the data on chain to see if it's correct and then mess around with it. This is really useful because storage costs on chain, like if you're trying to store on-chain state is like very expensive for good reason. And so it's best to, and if you want to create millions and millions of NFTs, that means millions and millions of token accounts, millions and millions of whatever. You want to be able to actually save that and not spend thousands of SOL just trying to make accounts for NFTs.
Yeah, cool. Thanks for that intro. So I imagine you have some sort of demo for us.
Yeah.
What are we doing today?
So before we get into the code, I want to give some context onto what we're working on. So one of all of this kind of came about a couple weeks ago, last week of January, when our friend Joey was talking about Stockpile, and he was like, "Hey, we're trying to do this Kickstarter thing. It would be cool to have a game on there." And I was like, "I like building games." And so I started ideating around this game called Legends of the Sun, which is like this RuneScape, dual arena style game, etc. I'm not going to get too much into the game or all the things about it, but if you want to check it out, we just tweeted out our website, legendsofthesun.com. We're going to be publishing it for CHAC. But one of the things was, hey, in this game, there are going to be items. These items are going to be like, tens of thousands of items potentially, like RuneScape. How do we give people these items on chain? If we say that we have, I don't know, 10,000 items or even 1,000 items and 10,000 players, or 10,000 items and 1,000 players, that's 10 million accounts. That's going to be about 20,000 SOL in rent. That's a lot of SOL. 20,000 SOL is a lot of SOL. And if we did this with compression, it would be 7 SOL, a drastic decrease, right? Plus transaction costs.
Wow.
But 7, sorry, go ahead.
Yeah, wow. That's a big difference.
So like, massive difference, right? Massive difference. So, but the problem with compression is the only use case, the only thing that people have been talking about compression with is compressed NFTs. These don't really work for game items. For example, if you've ever played RuneScape or any kind of game, you might have multiple copies of the same item. In Solana land, we call these semi-fungible tokens, which is a word I hate. I try to call them tradables or compressed tradables in the land that we're going to be talking about them in. But if you're coming from Solana and you're trying to understand what this is, these are semi-fungible tokens. Basically, it's an NFT with a value greater than one, right? So, like for example, if I have a swordfish, I have a token with some metadata, but I might have more than one of it. Unlike a fungible token, which is more like a currency, or an NFT, which is like a singular item. And so one of the things we started working on was this idea that, okay, can we make, we can't, the compressed NFT standard allows us to make compressed NFTs, but we want to make compressed tradables. How do we do that? So the idea was we need to come up with generalized compression. We need to be able to take the compression standard and allow it to use any kind of data that we can put into it. So this actually originated from the idea that TinySPL and Nelson over at Spear came up with, which was hijacking the URI field. So a little context here: TinySPL is an experiment that Nelson over at Spear did on using the UTXO model, so creating NFT receipts for tokens. So say you have 100 tokens, you have a receipt that says you have 100 tokens. Now you want to spend 20 tokens, you burn that receipt and you create two tokens, one that says you have 80, one that says you have 20, and then you transfer the 20 receipt to somebody else. They want to spend 40 tokens, they have a 20 receipt, they have another 20 receipt, they combine them, and now they have a receipt for 40 that they give to somebody else. This is how Bitcoin works. This is called the UTXO model, etc. This needed to happen because we didn't have update metadata. A couple weeks ago, update metadata landed, or like a month or so ago, update metadata landed on mainnet. Update metadata allows us to update the metadata of the compressed NFT. And so the way this the TinySPL hack worked, and the way my hack works, is we take the URI field that's in the metadata, which gives us 200 bytes of output that we can just, or input that we can just shove whatever bytes that we want in. This allows us to really just treat it like a buffer, treat it like an account inside of an account. The challenge then becomes, okay, I shoved 200 bytes of data in there. How do I read it? How do I read it on my Solana program? How do I read it on my client side? How does the RPC know what that data is? Excuse me. And so on. So what we did there, and I'll show the code in just a second here, is we can use something called flat buffers. So if you've used protocol buffers, you might have used Captain Proto, you might have used protocol, I think Protobuf is another one. All of these kind of messaging serialization formats. Flat buffers I like because it has universal support, like it has really good support across multiple languages. But the idea is you define a schema, you store the schema in a collection NFT, that's a standard NFT, and then you mint compressed token accounts for each token, or for each user that has that token. So just like Solana, you have ATAs or token accounts for every token per user. You can mint compressed token accounts with the amount being inside the metadata of the NFT, and then you can update it by deserializing it using the schema that's in the collection, and edit it, do whatever you want. And then RPCs basically out of the box without having to change anything are dumb RPCs. They will index the data and the schema and they serve it to you so you can deserialize it. Or if they want to be smart RPCs, they can go ahead and index like hot schemas, like popular schemas. For example, if compressed token accounts became a very popular schema, and they could give you that deserialized data straight away. So they don't have to change anything, but if they wanted to work with us, or they wanted to add more, DevX experience for generalized compression, they definitely can. So pausing there real quick to just see if there are any questions anyone has before I dive into the code.
Yeah, super cool. I don't see any chats anywhere.
Cool. So let's present. Oh, I might have to restart it because I have to give permission.
Yeah, that's fine.
Quit
It
and
shouldn't hurt
reopen.
anything.
I'll be
Cool. Wait, where's the hold music? All right.
okay. Let's see if
Boom
that
and
shows up.
boom. It
Cool.
shows up. I'll try to make it a little bigger, and
Yeah,
you'll
I
probably
can
need to
zoom in as
in a
well.
ton.
Sorry. Yeah, I have obnoxious. One of my obnoxious traits is this is the level that I usually code at, if not smaller.
Yeah, let's see what would be best. Maybe if we like.
Okay.
That's maybe like one more tick zoomed in.
Cool. Is that better?
Yeah, that looks readable. Yeah, looking at the Twitch right now, looks good.
Okay. So before we get into anything, I want to just talk about a couple of APIs that we have. So one of the things that we're talking about, like we were talking about the game, is okay. Now you have these items. We also have we're going to be able to build a CLOB with these items using Phoenix. So CLOB stands for Central Limit Order Book. Basically, when you have a lot of compressed token accounts, or whenever you have a lot of like low liquidity items, like you have 500 swordfish, I have 200 swords, whatever. There's not enough liquidity in the market to use AMMs. We need to use a central limit order book. So one of the things that we'll also be doing is building a central limit order book for compressed token accounts using Phoenix by building a market maker on top of that. We'll get into that a little bit later. But basically, the API here is split into two parts. We're called this Grand Bazaar. All of this is open source, available on github.com/spaceman-collective if you want to look at the code yourself. It's a work in progress right now, but all of our changes, like all the Rust code, is public. We're gonna probably close source the game itself, which is a Web 2 game, and close source the front end for the NFT marketplace that we're going to launch with this. But the Rust code, on-chain code, we're going to keep open source. So really quickly, what's happening here, and you can kind of see actually back I was drawing this out for somebody on the whiteboard, is that we first initialize a game NFT. This is a traditional NFT, so this program could be used by multiple games if they so wanted to. We're going to go into the handler in just a bit, but this is just a traditional NFT. This is going to be a collection, and this collection is going to hold other collections. Then we're going to mint item collection. Item collection is, say, a blueprint for an item. So say my game is Legends of the Sun, then my blueprint item is, I don't know, Bastard Sword of the Moon or something. And then we're going to mint the item account. This is the mint compressed token account. And this is where the cool stuff happens here, where we're actually going to take a set of bytes and throw it in to the URI field and have it be there. The next part we don't actually have a test for yet, but this is where I was working last night. So we'll have this in probably another day or two, is how to update that account. And so I'll show the code for it as well, but basically how to make the flat buffers schema and all these things. So really quickly, the first two are going to look very similar. This is just, these are just handlers for the creating, creating metadata. So you just mint a token, create metadata. This is very standard Metaplex stuff. You can see it in their docs. Boom, boom, boom. Some of this might need to be cleaned up a little. But yeah, this is pretty standard. Same thing with item collection. So I'm going to jump into mint item account. This is where the magic happens. And here, these couple of lines are all that we really want to look at. This is just going to mint the account itself. But really what we're doing is, again, this hack is very simple. We're just taking the URI, item metadata. We're going to deserialize it. The data string is going to be, so basically, if you pass in a string of 01001 or whatever, we're just going to take that string, turn that data, or turn that vector of U8s that you pass in, whatever that byte length is, turn it into a string, because the URI field will type check that it's a string, and turn it into a string of 01101, whatever the bytes are. So all we're doing here is converting from the vector of U8s to a string, so we can store it in the URI format, which costs us a little bit of compute. One of the things that we make sure is that it's not above 200, which I could actually probably put 200 there because I think you can do exactly 200. And that's because the URI field is 200. If we forked Bubblegum, or if there was a change in Bubblegum, so one of the things we're going to be doing is proposing a Metaplex improvement proposal for a new leaf schema where we can potentially store in more data than 200 bytes. But 200 bytes is a fair, it's a decent amount for like a lot of things that you want to do. Compressed token accounts, we just need to store an amount in there, which is 8 bytes. So we got plenty of space.
And maybe a quick thing.
Yeah.
So since this is compressed, that just ends up being like a CPI, not actually going on chain, right? You're not.
It goes on the ledger, not on the on-chain state.
Yeah.
The
Okay.
nuance there is that ledger state can't be accessed on chain, but you can verify it on chain using the Merkle hash that's available.
Mm-hmm.
It's
Okay,
confusing, cool. I know, but if I can answer more questions about it, I'm happy to.
Yeah, I was just wondering because when you make the traditional like Metaplex accounts, that URI is on chain. So if you were doing this hack, you would actually pay for more storage. Like you're actually storing something. It wouldn't work in that case, right?
No. You're not storing this on chain. You're storing the hash of this on chain. But yes, if you wanted to store this data on chain, then you would just be using a token account.
Yep, and that would cost money. Yep.
Yeah. So again, that 20,000 SOL difference versus the 7 SOL difference for 10 million accounts.
Yeah.
Right, because all we're doing here is hashing this and then storing the hash of this inside of Merkle. And then this is a very standard minting, mint to collection is for Bubblegum. We're just going to mint a Bubblegum thing. So we have tests for all of these things working. I can show you if that is of interest, but it's not really sure. Bash scripts validator. These are just warnings because I have a lot of skeleton code. Scripts tests. So it minted an item account. It was able to no op into Bubblegum. I'm going to zoom out just a little bit just so you guys can see that we did Bubblegum program here. We were able to mint one, append, blah, 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 blah. And the instruction took about 100K CU units or compute units, which is a lot, but like it's, it's well within bounds of what well within bounds of the 200K limit that we need. This gets kind of interesting when we go into other approaches to generalized compression. For example, there's another team here. I don't know if I can actually talk about it just yet, but they're working on ZK generalized compression. Their approach allows you to do not use lookup tables, but it is a slightly heavier function call, which means less composability overall. But yeah, 105K CU. So and then finally, the thing that I want to show is how to deserialize this data and do the flat buffer stuff. So if we go to, let me switch over to the main branch. And if I want to do mint to item account, I haven't finished this function yet, but it's interesting to take a look at because this is how you would, so in schemas, I have the schema file, which is flat buffers file, and I can zoom in more here. This is just this, the syntax for flat buffers. You can read about it on flatbuffers.dev. But I have this concept of a compressed token account, and all it has is a collection ID, which really I don't really need because the Bubblegum already has this. But I figured, I have 200 bytes to deal with. Might as well throw something in there useful. And then the amount, which is going to be a U64, that's 8 bytes. I can throw in more data here if I wanted to, like delegation and all these other things, but I don't need to use it. If someone wants to feel strongly that that should be included, we can include that. But otherwise, all we really need is an amount field. Then you can do flat C, which is the flat buffers compiler. So if I do here. CD source schemas, programs, are schemas. I do flat C, or flat C pack Rust, token account.fbs. This generates a Rust file, which I already have, but in case, that's the command to do so. This Rust file can then be included in your code with so you just like any other Rust file, you mod it, right? So here I have it, pub mod compressed token account generated, use everything, librs, mod schemas, and then you can bring it in to your code here. And then basically you get the buffers from the metadata args, right? So you get the URI. It's going to be a string, which is fine. You just map the string to chars and break it up. Actually, I think I have to split this. This will not work, but that will, yeah. Split, join. I'll deal with this later. But what I'm doing here is like you basically have a string here that's like this. And what we want to do is just join it here. And like break it up and then do 0, 1s, whatever. And yeah, then we collect it. Then we generate the flat buffers account with it, the compressed token account. And that's just using flat buffers, root, compressed token account, pass in the compressed buffer, unwrap it. You can set the new amount, and then you just do update metadata, which is the standard bubblegum call. So yeah, that would be the way to update your data and all these things.
Wow, cool. Man, this is cool and eye-opening. Wonder how much you can shove in a URI now.
200, like 200 bytes. You can do whatever you want, and then if we could get the MIP passed, then potentially more than 200 bytes. But honestly, like 200 bytes, like plenty of space for you to do compressed stuff with.
Do you think there's do you think incentives aren't aligned there for like the indexers? Will they not want that to be super big?
No, because they already do that kind of. They already index the entire space for the MPL and bubblegum. The only reason they don't want more space is because there's no reason for them to not want more space. It's just a different leaf schema for them to keep track of.
Okay.
So the only thing that it would mess up for validators is that like, oh, now it would be like a different schema that they have to keep track of. But this is perfectly aligned with validators or RPC providers. If they're running DOS, then they can run this without any additional overhead.
Very cool. Super cool. All right. Do we have any questions from anyone? I'll put a few people on the stage. Feel free to unmute if you have a question. I'll check the other chats too. Not much.
Yeah, that was the biggest concern that we had when we were coming up with this. Is like, as a project, we can't go to an RPC and say, "Hey, you should change something for us." So we needed a product. We needed a solution that would work today without any changes to RPCs, without any kind of incentive change or anything like that. So that was the primary motivation.
Yeah, that is cool. Do these assets still show up in a wallet? Do they just look kind of dead?
They will show up as compressed tokens or compressed NFTs.
Yeah.
But yeah, they'll look kind of dead. We would need a special viewer in wallets and stuff to be able to view them. So that's one of the reasons that on our marketplace we'll have like a viewer for our token, like compressed token accounts.
Okay.
But hopefully we can get like wallets to support it. Maybe we'll write an XNFT as a plugin. But yeah, they'll show up as compressed NFTs and then they'll be kind of dead.
Okay. But yeah, for your use case, that's still pretty cool.
Yeah.
You just want to store the asset for the user in the game. Yeah, that's sweet.
Yep.
Very cool. Yeah, where should we go from here? Do you have anything else?
Nothing
much
else.
it.
I would just, the only thing I would say is if you're interested in checking out our project that we'll be using this for, it's again legendofthesun.com. Let me see if I can bring it up here.
Yeah, bring it up. I sent a link in Discord as well.
Perfect. But yeah, so we'll be working on a couple of things. Yeah. We'll be launching on Stockpile very soon. So check it out, follow our Twitter, and we'll keep you up to date with more information.
Yeah. Very cool. All right. Yeah. Well, we could just wrap it up. Call it a short one. I want to go look at your code more. I haven't written too much Solana Rust. I just like staring at it from other people. So this is fun.
It's the reality of the situation was like we were kind of surprised of how easy the hack was, but it's kind of only possible now that we have update metadata.
Yeah. Yeah, that is pretty cool.
Yeah.
Yeah, if you're really, if you just need some like cheap game state for like anything, you could follow something like this. Even just
we've been talking with a bunch of other projects here, like Buddy Link and so on. Like a lot of people's biggest complaint is that, oh, I need to make big accounts, or I need to make accounts. And if your account is under 200 bytes and you can store it as a compressed account, well, now your users don't even have to pay anything. You can like subsidize costs for 10 million accounts for like nothing.
Yeah, that's pretty big. That is cool. Well, sweet. Well, Spaceman, thanks a ton for being here. This is super fun. As always, this is recorded, so this will be on YouTube, and we'll keep doing them every week.
Cool.
Thanks again. We'll see you next week. Bye.
See ya.